So today I am going to deal about the subject of principles of compiler design. In this, the main topic is top-down parser. So what is top-down parser means? A top-down parser builds the parse tree in which starting from top to bottom, that is top represents the starting symbol and the bottom represents the yield of the string, or it mainly the top represents always it consists of the non-terminals and the yield consists of the terminals. We can have two kinds of parser, top-down parser. First one is top-down parser without backtracking and top-down parser with backtracking. First of all, top-down parser with backtracking means we have to use brute force method. So what is brute force method means? We have to analyze all the possibilities, and if any one of the possibilities is wrong, we have to backtrack. That is the main aim of top-down parser with backtracking. If second one is we can have top-down parser without backtracking. So in backtracking we can have some of the drawbacks in backtracking, because nowadays the backtracking is not at all used in the programming language constructs, and also it's not at all more efficient, and also it's more cost. Where if we can have more than one productions or multiple productions in the grammar, then so we can go for the backtracking without top-down parser without backtracking. So this is an example for top-down parser with backtracking. So given this is the context-free grammar. Given grammar, this S represents this start symbol, and whatever present this is this is the production, and whatever present on the left hand side, this is called as all the symbols which is present on the left hand side, this is called as non-terminals, and whatever present on the left hand side we have to eliminate it, and the remaining symbols will be considered as the terminals. So here we are going to deal with the top-down parser. We are going to deal with the top-down parser with backtracking. So this is an example for context-free grammar. We have to start with the starting symbol, then we have to expand this starting symbol. So first we are going to start with the starting symbol, then by expanding this starting symbol we can have two alternatives. We can expand either RXD, or we can expand either RZD. Now I am going to expand the RXD. S can be expanded to RXD, and here we are having one input string. The output of our yield of this string is always read. We have to generate this as the yield. Next, when this input pointer is compared with this one in this parse tree, so both are equal. So we can move this input pointer forward one direction, one forward to move to one more direction. Then again this this X, now we came to this token X. This token can be again expanded to either 0A or EA. Now I am going to expand this X to 0A. Now this R, E, A, D we have. Now the input pointer points to E. So what about here? Here is we have O, but both are not equal. So we have to backtrack. One again. Now we have to see, is there any alternatives to expand the X again. So here we have one more alternatives, EA. So we are going to expand this X to EA. Now the input pointer is pointing to E. Here is The token is E. So we can move forward this input pointer one more position. Now the input pointer is A, and also the token will be here A. Both are equal. So again we have to forward this input pointer to one more position forward. Then here we are having D, here also D. So now we have building this input string read by using top down parser with backtracking. So this is but backtracking is not at all used nowadays in programming constructs, and also it's not efficient and it's more costly if the number of production is increased, or if we have multiple number of production, means it will be more costly. So now we cannot use this top down parser with backtracking. So we can go for one more parser. That parser is called as top down parser without backtracking. That is called as predictive parser. So predictive parser is one of the working model of the recursive design parser, which has the capability to predict which production is to be used to replace the given input string. Also, this predictive parsing does not require any backtracking. So what is predictive parsing here? What are all the components we have used under the predictive parser? The components are the parser algorithm, input pointer, then the stack, also the parsing table. So what is stack means? Stack is a linear data structures in which stack is a linear data structure in which follows the principles of last in and first out. That is, always the empty stack is in predictive parser, always this empty stack is represented by $, and at the end of the input buffer we are having one more buffer called as input buffer. At the end of input buffer, each and every end of the input buffer is represented by $, to represent the given input is to represent the end of input. Next we can have some parser algorithm to generate the yield or string, then by using this parsing table. So now I am going to explain about one of the recursive design parser. How can we generate the recursive design parser? So given we have one grammar E derives E plus T derives to T star F, and F derives to E or alternatives to ID. What are all the pre-processing steps for constructing the parsing table? First one is left recursion elimination. We have to eliminate the left recursive equations, then first computation, follow computation, then we have to design the predictive parsing table, and finally we have to construct the accepting table. So how we can eliminate the left recursive grammar equations? So here left recursive means if we have any algorithm like A derives A alpha or beta. So when we construct the parse tree for this one, the parse tree can be grown only on the left hand side, that is A derives to A alpha, and again A can be expanded to A alpha, then again the A can be expanded to A alpha. Like this it will be only the parse tree can be grown only on the left hand side, that is this is called as left skew. So in order to eliminate our predictive parser does not accept any parser with left recursive grammar. So we have to eliminate all those things by using some of the formulas. A derives to beta A dash, where this A dash represents alpha A dash or epsilon. So consider the grammar. This is the given grammar, right? E derives to E plus T, then T derives to T star F, and F derives to E or ID. That is our grammar is the given grammar will be E derives to E plus T and T derives to T star F or T or F then E derives to open E or ID. So how can we eliminate the left recursion? What is left recursion here is, on the left hand side we have one symbol, on the right hand side of the productions at the start of each and right hand side must be if it is equal to the left hand side, means this is called as left recursion. So this production will consist of some left recursion, and also here also T on the left hand side, right hand side of the production, starting symbol of the right hand side is equivalent to the left hand side. So this is also consists of left recursive grammar. Then this is not a left recursion. So we have to eliminate the left recursion for this production and also for this production. So here how we have to eliminate by using this formula, that is A derives to A alpha or beta. We have to write A derives to beta, then this left hand side A dash, then where this A dash is deriving to alpha A dash or epsilon. Okay. So by using this formula we are going to eliminate the left recursion from this grammar. So here E derives to, first here this both, whatever the repetitive symbol can be considered as the A, then the remaining symbol can be considered as alpha, then and after this alternative this will be considered as the beta. Then how to eliminate left recursion in this one means E derives to, first here beta here is T, then A dash means whatever present on the left hand side you have to keep it as the dash. Here left hand side the variable here is non-terminal is E, so we have to write only E dash. Then next where the E dash will be alpha A dash. So what are the alpha here? Alpha is plus T and the same E dash then or epsilon. Next here this production also left recursive grammar, so we have to eliminate this. Among this A, T will be acting as A and star F will be as alpha and F becomes the beta. So we have to eliminate this left recursion by T equal to beta A dash. Here beta is F, then what is A dash here means whatever present on the left hand side, that dash. So F T dash. Next where this T dash derives to alpha A dash. So here alpha is star F, A here is T dash, so T dash then or epsilon. Next last one, there is no left recursive grammar for this one, no left recursion here, so you have to write as it is. So first step in constructing the predictive parsing table is elimination of left recursion. Next step is we have to compute the first computation. If there is, what is first means, if there is a variable and from that variable we have to try all the strings whatever coming, and whatever the strings coming in the beginning of the string will be considered as the first computation. First of all terminal and non-terminal can be seen only on the left hand side. See our grammar here is after left recursion. E derives to T E dash. So terminal, first of all terminal, for first computation we have to compute for all terminals and also the non-terminals. The first rule here is first of all terminals are the terminals itself. So what are all the terminals here is, see what are all present on the left hand side can be considered the normal term, non-terminal, and whatever present, we have to eliminate all those left hand side variables or tokens, and the remaining symbols will be considered as the terminals. So here terminals are plus, star, open, close and ID. So for this, the first of all terminals are terminal itself. So first of here we have in our grammar, we can have the terminals are star, plus, open, close and ID. So for first of all these terminals are the terminal itself. So first of plus is plus, first of star is star, first of open is open, first of close is close and first of ID is ID itself. For non-terminals we have to compute something like that. For non-terminal, first of E, we have to calculate the first of E. So goes to the left hand side, find out where E is present. Here the first is present at the first production itself. So go to E and goes to the right hand side. What is the string we come across on the left hand right hand side? That is we have T. So but T is always the first, and follow computations contains only the terminals. So here first of E is T. This is a non-terminal, so you have to go to the T production. Then T production sir, freeze. So first of non-terminal E is, we have to calculate, goes to the previous left recursion grammar. E derives to T dash. First of E is, here is non-terminal T. So it's so goes to this non-terminal place. Then again you have to find out the first, whatever the first comes on the right hand side. So here F is also non-terminal, goes to this F production. Now F production consists of the terminal, open and ID. So this is the first of E is open and ID. Then goes to the finding out the computation of E dash. E dash means goes to, you can go to directly go to the E dash production, and from this E dash production what are all the strings coming on the first of E dash. E dash, first of E dash here is plus and epsilon. So first of E dash here is plus and epsilon. Then we have to find out the first of T. First of T means goes to the, see where your T present on the left hand side, that is goes to the production of T. From this T on the right hand side, it consists of only the F, which is a non-terminal. So you can go towards the non-terminal F production. Then this production consists of open and contains open and ID. So open and ID will be considered as the element first of T. Next we can go for first of T dash. First of T dash is T dash already always this it contains on the right hand side, it contains star and epsilon. So first of T dash is star and epsilon. Next first of F. Now first of F also consists of open and ID as the terminals. So first of F is open and ID. Next computation is, we have to compute for the follow computation. So what is follow computation? Follow means it is used to identify a terminal symbol immediately after a non-terminal in a given language. So follow of X to be the terminals that appear immediately in the right side of non-terminal X in some sentential form. So what is sentential form means the intermediate results in the process of derivation, either it's in the leftmost derivation or in the rightmost derivation, we can have some of the intermediate results. All those intermediate results will be considered as the sentential form. Next, take for starting symbol S. S is represented as the starting symbol. For always you have to keep $, for this starting symbol, because to indicate the stack is empty. Then we have to compute the follow computations, we have to follow some 3 rules. Suppose if it is a terminal means you can write the terminals as it's. Then suppose if we have some non-terminal, so here see, we are going to find out the follow of B. After B, what it comes, there is a non-terminal coming. So for finding out the follow of B, if any non-terminal comes means we have to find out the first of this non-terminal and plus union of follow of this left hand side symbol. Next, if nothing follows, that is we are having suppose if you want to find out the follow of B, if nothing follows after B means we have to find out the follow of left hand side itself. That is these are the rules to compute the follow symbols. Next, how can we calculate the follow computations? After left recursion elimination, our grammar becomes E derives to TE dash, where your E dash derives to plus TE dash or epsilon, then where T derives to FT dash, where this T dash deriving to star FT dash or epsilon, then E derives to open or ID. This is the grammar after left recursion can be eliminated. Next, from this one we are going to find out the follow computation. In follow computation there is no epsilon computation. There is no epsilons are not allowed in the follow computation, and follow can be computed only for the non-terminals, not for the terminals. Not for the terminals. Okay, so how can we calculate the follow of E? First symbol. So whatever the follow of, to calculate the follow of E. So since E is the starting symbol, so you have to first include $. For each and every starting symbol we have to include $. For this. Next, follow can be computed only on the right hand side of the productions. So find out where this E presents. So here E is present at this place, nothing is there. So after E we can have close symbol. So this is the symbol, this is the terminal. So whenever if any terminal comes means the first rule will be applied, that is if any terminal comes means we have to use the terminal itself. This is the follow of E. Next, follow of, we have to calculate the follow of E dash. So what is follow of E dash? Go to the right side of this production and find out where the E dash present. Here E dash present here and here in the first production, and also E dash present in the second production also. So in both the productions nothing follows. If nothing follows means rule 2 will be applied, that is we have to find out the follow of E itself. So what is follow of E? Follow of E itself means you have to include this. So follow of E dash is equal to follow of which is equal to follow of E itself. Next we can go find out the follow of T. How we can go compute from this left recursive grammar, find out where this E present. E present here and also E is present here. Then what is come after E? After T we have E dash comes. So V dash is the non-terminal. For non-terminal we have to find out the first of this non-terminal plus union of first of, that is first of whatever the non-terminal comes here is E dash union of the follow of left hand side. So here left hand side we are having E. So what is first of E dash? Already we have computed the first of, E dash is plus and epsilon. So under follow computation no need to include epsilon. So and first of E dash is plus comma epsilon union. For this epsilon we have to compute the follow of E. What is follow of E? Already we are having dollar and close. So we have to compute union, make union of it. Follow of T is plus dollar and close. Next we are going to compute the follow of T dash. What is follow of where T dash present here in this one? T dash present at the left side, nothing follows in the left hand, nothing follows after T dash. So we have to find out only the follow of T, whatever follow of T. So follow of T dash is equal to follow of T itself. So whatever present in this T, we have to include this plus dollar and close in the follow of T dash also. Next finally we have to find out the follow of F, where your F present here. F is present over in this T production and also in this T dash production. After this T and after this F we are having T dash. So T dash is one of the non-terminal. If any non-terminal comes means we have to find out if follow of F means we have to find out if any for non-terminal comes means we have to find out the first of that non-terminal, that is first of that non-terminal is T dash union of follow of T. So what is first of T dash? Already we have computed. First of T dash is star and epsilon. So first of T dash is star and epsilon. Then for this epsilon we have to compute the follow of T. Union of follow of T over here is follow of T is plus dollar and close. Then finally you have to make union of all those things, star plus dollar and close. This is the final follow computation for this F. Then next step is, so we have to write all those things for each and every, write the first and follow for each and every productions of E, E dash, T, T dash and F. The final predictive parsing table. How can we construct this predictive parsing table? We have to construct this predictive parsing table from this first and follow. Okay. So what is the first of for this production? What is the first over here? ID and so this predictive parsing table can be constructed by rows. Column consists of the terminals, and row consists of only the non-terminals. Each and every row, what are all the non-terminals we are using under the grammar we have to use. Here the non-terminals used under the grammars are E, E dash, T, T dash and F, and the terminals are ID plus star, open, close and dollar. Now we are going to fill up all those things. What is the for the first production? First production is E derives to T E dash. This consists of ID, and first of this production is ID and close. So first mark ID and close. Under this ID and close, you have to write the production of E derives to T dash, E production of T dash. You have to write under the column of ID and open. Next, for E dash production, the E dash production for E dash is plus T dash or epsilon. Then first of this is plus or epsilon. So first is plus or epsilon. So under plus you have to, so this production is plus T E dash, E derives to plus T E dash or epsilon. Then first of this one is plus and epsilon. So and here we are having plus, so here also plus. So first choose plus here. Under this you have to write this production plus T E dash, under this E dash derives to plus T E dash under plus. And for epsilon we have to go to the follow of, for each and every epsilon production we have to go to the follow computation. So follow for this E dash derives to plus T E dash or epsilon is dollar close. So you have to choose dollar and close. Under dollar and close column you have to write E dash derives to epsilon and E dash derives to epsilon alternatives. Next, what is first of T? First of T is T derives the, here the production, production for here is T derives to F T dash. Then what is first of here? First of this T is ID or open. So first here is ID or open. You have to choose both ID and open. Under this column of ID and open you have to write this production T derives to T F T dash and T derives to F T dash. Then you can go for the next production T star. So what about T dash? T dash derives to star, T dash derives to star F T dash or epsilon. First is star epsilon. So for star, under the star you have to choose this star column, and under the star column you have to write this alternative star ft dash. T dash derives to like this, star ft dash. Then what about this epsilon? For this epsilon we have to find out the follow of this T dash is plus dollar close. So follow of T dash is plus dollar and close. Okay. So you have to choose all those things. Plus dollar and close. First choose the column under plus dollar and close. Under that one you have to write the remaining alternatives. T dash derives to epsilon, T dash derives to star epsilon here and here. Then finally you have to find out the first of f. F is equal to id, and first of f is, already we know, first of f is id and close. Okay, first of f is id and close. Then you have to choose so first of f here is open and id and open. So for this under you have to choose the column of id and open. Then what's the production for f? The production for f is id or e. Production for f is equal to id or e. So under this id you have to write the first alternatives. F tends to, f derives to id, and under this open we are having open, so choose this open. Then under this you have to write f derives to e, open close e. Next we have to find out whether the given string is, we have to find out whether the given string is accepted or not. So this is the final predictive parsing table. We have to find out the accepting table for this predictive parsing table. So accepting table will be accepting table consists of, first it contains the stack, then input, then it consists of the string. Stack usually contains the empty stack represented as dollar, and suppose if you want to find out for the input string id plus id, for even the input string is id plus id. So here under input string first write id plus id, then finally input buffer must be ended with the dollar, then what are all the output here. Okay, first dollar and id. From this parsing table we have to find out where is the dollar and id. Makes this first e as the first symbol, then we have to find out the e. From this e and id, what is the production we are here. Here the production we are having here is e derives to t e dash. Then this will be written in the recursive reverse order inside the stack, like e dash, instead of e you have to write t e dash in the reverse order like this. So e dash t, then id plus id and dollar. Next we have to find out on this column, on this row, t's rows and id column, what is the production here? The production over here is t derives to f t dash. So again we have to write, instead of t we have to write t f t dash in the reverse order. So dollar e dash t dash f, and id, we have to continue this process up to both the stack is contains dollar and input buffer contains dollar. Then this will be considered as the accepting state. This will be considered as the accepting state. That is, the given string is id plus given string here is id plus id will be accepted for the given grammar. So that's okay. Thank you so much.